Okay, let's take a look at these three compounds, figure out what the formula is, and then figure out the molar mass. For the first compound, I'm given ammonium phosphate. These are the two ions, ammonium and phosphate. You have to remember their names, you have to remember their charges, you have to remember their formulas to be able to do problems like these. Oops, and I have the wrong. Okay, let's take a look at how to figure out the molar masses of these compounds. First of all, let's figure out how to write the formulas for these three compounds. I have just written the ions here. For the first one, we have ammonium phosphate. You have to memorize the polyatomic ions, their names, their formulas, and their charges. This is my ammonium ion, and ammonium ion is the only polyatomic ion that we're going to talk about that has a positive charge. It's a +1 charge. The phosphate ion is a 3- charge. And therefore, when we go to write a formula for this, a neutral formula for this compound, we need, and don't get confused by that 4 of the hydrogen. We need 3 units of NH4, so 3 of these, because each one of them has a +1 charge to balance that 3-. And therefore, I can put this in parentheses and put a little subscript here, which denotes that I have 3 of whatever's inside here. Okay, let's do this one. I have manganese 2 nitrate. That little 2 in Roman numeral tells me the charge on the manganese. Manganese is a transition metal, which means that it actually has more than one charge, or it forms ion with more than one charge, but that Roman numeral tells us that it's a +2. The nitrate is a -1 ion, and therefore to make this a neutral compound, I need 2 nitrates, because each of these nitrates has a -1 charge for a total of -2. And then a subscript tells me I have 2 of whatever's inside the parentheses. And the last compound is dinitrogen heptoxide. This is a covalent compound because it's 2 nonmetals, and the prefixes tells me how many of each element I have. Dinitrogen tells me I have 2. Heptoxide, hepta stands for 7, so this is the formula, N2O7. Now that I have the formulas, I can figure out the molar mass. Remember, I multiply as I distribute throughout this parenthesis, so I have 3 nitrogens. 3 times each nitrogen is 14.01 plus, now I have to figure out the hydrogens. It's 3 times 4, not 3 plus, but 3 times 4, so 12 hydrogens. Each of them have 1.008 plus I have 1 phosphorus, which is 30.97. And then lastly, I have 4 oxygens, so 4 times 16. And if you do all of this math, you should get approximately 149.09 grams per mole. So every 1 mole of ammonium phosphate weighs 149.09. Remember, the idea of the mole is just a measurement unit. Okay, it's like a dozen or a pair, except that the mole is 6.022 times 10 to the 23rd. Okay, let's look at this formula over here, or the molar mass. I have 1 manganese, and manganese is 54.94, so 1 times 54.94 14.94 plus, now I have to distribute. I have 2 times 1, so 2 nitrogens. 2 times 14.01 plus 2 times 3 oxygens makes 6 times 16. And if you do this whole math, you should get 178.95 grams per mole. Let's look at the last problem. I have 2 nitrogens, so 2 times 14.01 plus 7 oxygens, so 7 times 16. And if you do that math, you should get approximately 140.01 grams per mole. Okay, this is a review on how to calculate the molar mass. The next couple of slides, we will review how to calculate moles from given an amount in grams or grams given an amount in moles.